Hello guys, so welcome to this part of this course, Visual Vision Language Models and the Applications. Now, in previous lessons, we obtained the drone's target position through aw.getPosition object name. Now, this approach uses the Unreal Engine's built-in capabilities to get ground truth data. In real-world drone applications, we need to implement the full OODA, the observation, orientation, decision, and action loop. And in this lesson, we need to use this scene to enable the drone perceive the environment, complete target detection, feed the result to the LLM, and make decisions based on LLM reasoning. Now, this is what this scene looks like. Now, to enable the drone perceive this scenario, we use what we call multimodal LLMs. Multimodal LLMs are models capable of processing and understanding multiple data types, text, images, audio, video, etc. through alignment, precision, and generation technologies. So they bridge different data modalities to achieve comprehensive understanding. These are what we are going to use to understand this image, to enable the drone to understand this image in a real world scenario, since the drone can be simulated in a real world scenario, right? So we use multimodal LLMs to make sure that they understand what they are seeing so that they can help make decisions based on the visual data. Now, the multimodal LMs offer the following advantages. We have cross-modal understanding, we have generation capabilities, we have transfer learning, we have key technologies used here, alignment and fusion, we have pre-training, and we have generation and reasoning. Now, in application scenarios of multimodal LMs, we have multimodal assistants, we have autonomous systems, we have edge deployment, and we have research. Now, these are top model multimodal LLMs as of early 2025. We have GPT, we have Claude, we have DeepSeek, Gemini, Qwen, DeepSeek, GM4V, Meta Image Binds, OpenVL, Kimi. Now, it's important to know that when choosing a visual language model, we need to consider its vision capabilities, provider, costs, latency, privacy, and reliability, rather than relying solely on a benchmark rankings, right? So, image understanding with multimodal LLMs. These are top visual language models. Now, the visual language models are models used for understanding visual data. So this we have GPT 4.40, we have human vision, we have WVL, we have IntentVL, we have Meta Image Bind. Now these are key technologies and training, visual encoders, and alignment and decoding. We already talked about this, and the training stages, connection models, and all. Now, these are the application scenarios of visual language models. We have consumer applications in image captioning, describing image content. We have in using it for content creation. Most people use it for content creation. In enterprise aspects, we use it in the medical field, SEO analysis, in finance, document parsing, form extraction. In science, we have image analysis. Also in robotics and drones, we have multimodal perception for autonomous navigation, which is this utility we are going to be using here. Now let's get started with this. Now for the purpose of this lesson, we are going to be using the API key of IO Intelligence, io.net, for multimodal LLMs. So we are going to practice it now and see what it's capable of. So get your API key from io.net in IO Intelligence, input it in this first cell. Also note that you're not supposed to do this, you're not supposed to input your API key in the notebook. It's supposed to be environment variable on your system, right? So I'm just doing this so that you can understand what I'm doing. Now this is the API key, I put it here. Also note that these cells are dependent on one another. So this cell needs to run before this cell. This cell needs to also run before this cell so that it can work also. So I've put it in my API key. Now this particular cell, it installs the OpenAI library. Now this is the API key. It uses the API key and the base URL. This is the IO intelligence endpoint where all information is sent to. This is the API endpoint. Alright. Now this next cell encodes the image, right? So that in a way that the language model can understand. So it encodes the image here, it reads it. The image is the first image I showed you before, right? So it finds the part of that image. This is the part of that image. And the model we are using is Moonshot AI Kimi K2.6. Now this is the role user content, and this is the instruction. What objects are in this image, right? So it answers what objects are in the image, and it sends it to the URL. That's the endpoint here. All right. Now this is it pins the response. Now this is the entire response. It's quite much, but you can see that the LLM is doing its work. Now this helps the drone understand the visual data so that it can respond and take a next course of action. All right, this is the next one. So this instruction we are using Moonshot AI again. Give me K2.6. Now we are asking what objects are in this image. Just give me the names. So this is a more specific and precise instruction. Only list common, clearly visible objects, separates multiple object names with commas. Also know that I already run these cells before, so that's why the outputs are already showing. So for you to run cells, you just highlight the cell and press here, and it's going to run. Or make sure that you run the previous cell before that, so that can work. All right, so this is the next one. So you can see that the output gives precise precise and anti-precise answer, not like this one. So because this instruction is more refined. All right, so this is the next one. Now see it says describe the position of the rubber duck in the image. So now we are helping the drone understand where the position of the rubber duck in the image is. All right, so this we're using the motion AI again, we're using the motion model, and this encodes the image and passes it to the URL for processing. Now it prints the response. Now you can see that the image joke is positioned on top left grid cube in the back portion of the grassy area. Let's check it out whether it's correct. Alright. Alright. So you can see that this is correct right now. You can see this is correct. Alright. So you can see more specifically sit on the cube that is left, right, and center, and you can see that everything is saying is correct. So this is how visual language models work. Now for this last cell imports CV2. CV2 is library used for opening image files and manipulating them. Base64, we always talk about this before, it encodes the file in a way that the AI model can understand it. Right. So this is a function, right? It converts the OpenCV numpy array into a base64 string, then it encodes it, right, using base64. Then it reads the image path of the system. So now this is our instruction sent to this URL path. So now it describes this image. You're asking it now to describe this image, right? So this is the description of the image. So it is now describing the entire image, what it sees. Also from this description, you can now fine tune it into what you want. What are you looking for? What are you saying? What's the next course of action and all that. So this is all for this section. I'll see you guys on the next section. Bye guys.